Alrighty, welcome back to Radicals. This is part 2, and I've got an example sitting here. We're going to kind of warm up with that example. We're looking for the fourth root of 16x to the 8. And another way of looking at that is saying, I need to form 4 groups here, okay, and each group has to be identical. That's what we're looking for. So, what times what times what times what can become 16? And you'd probably say, I think that has to be a 2. You would be right. And then I need something times something times something times something to make x to the 8, and you would be correct in saying x squared. Okay? Because remember that these little bundles have to be identical, and we also want our exponents to add together and make the number 8. So our answer would be 2x squared. That's the fourth root of 16x to the 8. All right, let's up the ante a little bit more with our next example. Let's make it a little bit messier. We're going to make a cube root of, and we're going to throw at you negative 27 and maybe x to the 12. And a y cubed. So that looks pretty good. All right. Now, because it's a cube root, we're looking at making 3 groups. But I feel a little bit more in these groups, though, because we got more variables and stuff on the go. And we want to make each little bundle here identical. So I'm thinking negative 3 times negative 3 times negative 3. So that looks pretty good. Then I've got to go x to the something, and x to the something, and x to the something, and they got to add up to 12 here. So I'm thinking 4, 4, and 4. And then I need a y cubed, so I better throw a y in the mix as well. So there it is. So my answer is negative 3, x to the 4, and a y. All right. Well, now let's carry on to the next example. Next example, we're going to try and take the square root of negative 9. Now, this one's an interesting one because you're looking for something times itself, 2 groups that will turn into negative 9. And if you think about it, you know, you're kind of drawn towards maybe a 3 and a 3, but you got to make sure it's negative 9. And keep in mind, these little bundles have to be exactly the same. So even if you tried negative 3, this would also have to be negative 3. And guess what? That's making positive 9. If you think about it, there's no way to get something times itself that makes a negative 9. So there's no answer. So we use this little symbol here, which basically means empty set or no answer. It also could be interpreted that it means not possible, impossible. Okay, let's move on to some other stuff. Like how about a different way of writing these radicals? And I just want to refresh your memory. If you were going to write the square root of x, another way you could write that is x to the 1/2. Okay, it means exactly the same thing. Or if you wanted the cube root of x, okay, that can also be written as the base, or x, to the 1/3. Okay, now that's a kind of an important little trick, because the next thing that we're going to do now, I'm going to just clear the screen. Next thing we're going to do is we're going to try to take a bunch of radicals and rewrite them as a single radical. So let me show you what I'm talking about. Cube root of a 5th root of x squared. So you got kind of radicals within the radicals, and the instruction would be write this as a single radical, please. You know, right now you got more than one radical going on. So the best way to handle this is to rewrite all this stuff as powers. So kind of work from the inside out. We got x squared. Now what are we doing to x squared? We are taking the 5th root of x squared, so this would be raised to the 1/5. And on top of that, I'm going to use square brackets just to make it more clear. On top of that, we're taking the cube root of all this stuff. So that would be raised to the 1/3. Well, now I can go, oh, look, we have inner and outer and more outer exponents. Now the rule for that is you multiply inner and outer exponents together. So what my new exponent is essentially 2 times 1/5 times 1/3. Well, that's going to be 2 on the top and 15 on the bottom. So this is like saying x to the 2/15. All right, well, I'm supposed to write that now as a radical. So here's what I can do. That would be the 15th root of, and then I got this x squared on the inside. And there it is. Now we've written it as a single radical. So let's do one more of those, because those are just loads of fun. But once you catch on how they work, they're actually not too bad. So let's do another one of those. And that's where we're going to call it a day. So here we're going to have everything thrown at you. We've got the 4th root of, and then we'll throw a cube root of. And then inside there we're going to have an x squared and a y to the 5th. And that's what we want to take apart here. Okay? So what are we going to do here? Well, let's take the stuff that we have inside the bottom radical here, which is x squared, and y to the 5th. And what are we doing with that stuff? Well, oh, we're cube rooting it. So that would be raised to the 1/3. And what are we doing with all of that? Oh, we're 4th rooting all of that. So this is to the 1/4. Okay, so now everything inside the brackets here is affected by the 1/3 and by the 1/4. Maybe the easiest way to deal with that is just to work them one at a time. So this would be like saying x to the 2 times 1/3 times 1/4. So this is going to be my new exponent for x. Okay, and that's going to be 2 over 12. Now you'll notice I'm not canceling anything or simplifying that. There's a reason for that, which will be clear in a moment. Now let's look at the exponents for y. We have 5 times 1/3 times 1/4, and so that's going to be 5 times 1/3 times 1/4, which is 5 over 12. Okay, so we have y to the 5/12. Okay, well, both of these guys, I can see I am doing a I'm doing a 12th root of. So let's go ahead and do that. So 12th root of. So go right back to the radical form now, and I've got x squared, and I've got y to the 5th. And by golly, I think we've got our answer here. We've got the 12th root of x squared, y to the 5th, one single radical. So I think we're there. We're at the end of the line. So what I'm now going to do is call it a day, and we're going to come back with more stuff on radicals in a little while.